And our goal of the satellite project is to bring diversity to the space sector and democratize the use of space, to emphasize, to promote of the satellite usage and also the amateur radio community. Our stakeholder is QTech with the funding from ARDC. I will talk about this one in the next slide. And our missions, there are 4 missions. Two main things is the APRS payload competition and also the ground terminal competition. And the rest 2 is the APRS student mission and USF, which is we don't talk about today. And our satellite would be 2 unit CubeSat based on the bird bus, and we approach to the lean satellite. And our team member, most of them are students. And for the operation, we use the bird ground station network. So let's come to more detail in the specification of the satellite. The dimension of the satellite would be 100 by 100 by 227 millimeter, and the total weight is 1.8 kilogram as for the simulation from the CAT program. And our power generation, we will use 2 series and 8 parallel of solar cells. So we will have 16 cells. We will use the Azure Space solar cell with the beginning of light efficiency 29.5%. And the maximum voltage is 2.7 volt, and maximum current is 500 milliampere, and power is 1.2 watt. For the batteries, we will use AA type nickel metal hydride battery with the capacity of 2000 milliampere hour by 1.2 volts nominal voltage. And for the communication system, for the uplink and downlink rate, we will use 4,800 bit per second UHF. And for the uplink frequency, we will use 435 megahertz, and the downlink frequency would be around 437 megahertz. And for the antenna type, we will use the 2 UHF and 2 VHF dipole antennas. So let's come to the ARDC. What is that? So it is the amateur radio digital communications. They would like to funding on this project to provide to get more people to know the amateur radio, and also want to improve to demonstrate the technology of the APRS and also the space sector. And APRS, what is that? APRS is the automatic packet reporting system. We can pass through the messages such as position information, location, speed, altitude, or text messages, or emails, weather information, bulletins, and some other scientific data by APRS. And packet of the APRS, it will be sent over the AX.25 protocol using APRS K modulation, and this one will be done by a TNC, which is the terminal node controller, and the rate speed up to 1,200 bit per second on VHF. And this is the example of the package from International Space Station, Jupiter. The first column would be cosine. Let me show you. Wait a second. Okay, this one, the first column would be cosine from the source, and next column would be the part that the message will go through, and next one would be the cosine of the destination, and the last one would be the messages that we would like to send. Next is the more overview of the satellite. So our satellite will be 2 units of CubeSat, 10 centimeter times 10 centimeter times 22.7 centimeter, and will be adopt the design heritage of the BERT's CubeSat. And our satellite will go through the JQ program by JAXA, which is our launch service provider, and we'll go to ISS orbit, International Space Station orbit, which is 400 kilometer and roughly circular and have the 51.6 degree inclination, and we will use the amateur radio frequency. Next is the configuration of our satellite. Our satellite will look like this one, and we have 2 UHF and 2 VHF, and the structure would made from the aluminum, and this is inside of our satellite. On your right hand side, this one is our bus. We contain with the battery pack here, and OBC, which is the brain of the satellite, will give command to every subsystem to report the satellite tail and so on. And next one is the UHF transceiver from the commercial one. And in the middle of the satellite would be the APRS boards. 5 of them will be the winning competitor team payload that will go with our satellite here. And another 2 APRS board will be the reference for to do the for the dimension between back of one board to the back of one board would be 16 millimeter. And if you can see from here, the top of the transceiver, this is expected transceiver that we think it would be from the back of transceiver to the back of another board would be 2.4 millimeter. This one. And this one is the, I just want to say that we will put the center of mass around the middle of the satellite here and also here to the be inside JAXA constraint. And our structure, again, we will use the aluminum 6061T6 for the structure, and of course PCB will be FR4 with a thickness of 1.6 millimeter. And this one is the project timeline. The green one is the timeline of the competition. It divided by three phases. First phase, 2 phase, second phase, and the third one. And the timeline of the competition will compare with our development of our satellite also. For example, like in the end of the second phase would be the start of developing EM, both from the competitor and also ourselves. So we will do the thing at the same time, and in the end of December, the competitor will be ready to send the flight model to our side to do the integration and testing, and after that we will send it to the JAXA to launch. And next is our burst 8 mission that I would like to present about. The first one would be the APRS payload competition, and next is APRS ground terminal competition, and the rest of the mission would be the demonstration of low-cost UHF transceiver that we would like to develop for this satellite. And the last one is the APRS student mission. That this one we will not talk about this time. So for the APRS payload competition, The objective of this one is to increase the users of the material community, and the result would be improvement of the technical skill and democratization of space. So we expect to everyone can join our space project easily to everyone and using amateur radio. And this one is the example of the APRS payload block diagram. So the board can have like microcontroller unit like this, connect to the flash memory, and we'll have TNC. It could be both in the hardware or software, and transceiver here. And the computer can have both line from the power line 3.3 volts and also 5 volts. You can choose which one that you like to do your mission. And this one will connect to the 50-pin connector here. And this one will connect to the mission board through the CPLD, this one. And we also have another design of the board. Let me show you. Sorry. Okay, this one. So we also have this design. So this one is possibility to have both of design, either which one. So we are now in the decision phase of which one that we're gonna use. Okay, and this one is the APRS payload measurement. The board that you need to develop, it would be 85 millimeter. And this is the front view, and your right hand side is the top view of the board. So this one is the transceiver that we expected. After we research in the market, the highest one would be 12 millimeter of the height. So the total of the thickness of your board would be around 17 millimeter. This one, and this one is the female 50 pins connector that it required to be here. Yes, to be connected to our black pen board. Next is our competition. So we have the terms of call for participation, and then phase 1, phase 2, phase 2, phase 3, and after that will be the flight model, and the last one after our satellite launch will be the onboard competition. I will show you a little bit. So the first one, after everyone send our application, we will select the team that can that passed, and then we can go to the phase 2. It would be the proof of concept, and then we will select 10 teams. And you also need to do the engineering board for the phase 3, and the winner of the 5-team winner would continue do the flight model in here, and after that need to send the flight model to the to us to do the integration and testing, and then it will be launched by ISS. Okay, let me show you what we need for the phase 1. The application form will contain with the team composition, affiliation. This one is for to sign MOU in the phase 3, and will be contain mission definition and also payload block diagram roughly, and also the preliminary budget plan. And next would be schedule of your project, that your development, and then this is the important thing, which is the plan of outreach, because we need to broadcasting the competition and the APRS thing and amateur radio. So yeah, you need to do the plan for outreach in your country and so on. And next one, we also require the quality of application and also the consent of open sourcing. On this phase, we will provide you the ICD and also the webinar from time to time for the technical information and everything. So this phase will be in the middle of March. I will show you the schedule here. So now we are open for the application, and the first webinar is already held. This one is the second webinar. Also, next one would be held on the 8th of February. This is here, and the please remember the deadline of the application would be the end of February, and we will spend 2 weeks to select the team that can go through the second phase. So on the middle of the March will be the end of the phase 1. So come to the point allocation. We will give extra point for the developing country, 5 points. And for the team composition, the maximum would be 5 points. For example, if you are our students up to master degree student, you will get 5 points for this one. And if you are mixed student and professional, you will get 3 points. And if you are all professional or PhD students, you will get 2 points. And next one, we'll give a lot, like 30 points. You will need to submit the motivation, objectives, and expected outcome and mission definition. And after that would be 10 points for each, would be block diagram for payload, roughly, the concept of operations, preliminary budget plan, and also schedule and plan of outreach. And the last one would be quality of the application and video explanation. So when you pass phase 1, come to phase 2. We also require some documents more detail. The first one would be system block diagram in more detail and seriously. And after that, you will know what component that you will use. So you can provide us the bill of materials, BOM. And next is the feasibility study and functional test, and also the safety compliance. And the schedule that you have done, the update that were you in the schedule, and also the result of the outreach that you have done before, I mean, in phase 1 and also phase 2, and the budget plan that you, how much that you spend and how much you're gonna spend more. And this phase, you will need to present to us what are you working with and so on. And this phase, we will also provide an ICD and also the webinar continuously. This phase will be the proof of concept. And in the end of May will be end of the phase 2. I will show you in here. So you can have like 2 months of development, and the deadline of submission would be the beginning of May. And we will spend 4 weeks to evaluate, and then we will announce the 10 team that's selected in the end of May. And this one is the point allocation. We will give a lot, 20 points to the system block diagram. And next is the bill of material, which the component characteristic. And then we also give 40 points for the feasibility study and functional test, would be contained with the power budget and mass and volume of for each component of the total mass of the payload. And next would be concept of operation, and last one would be the preliminary link budget. And next one would be 10 points for safety compliance. This one is how to avoid interference to other subsystem emergency plan. and also how to isolate the payload from the satellite during the emergency. And next one would be the quality of submission. We will give 5 points to you. And for schedule will be 10 points, and the outreach that you have done will be 10 points. So come to phase number 3. Our requirements will be different now. So we will need the engineering model, and together with the functional test report that you have done to your EM board engineering model. And then we will need software operation manual, for example, like to program the MCU. And then it will be link budget. And at the same time, you will need to provide a schematic board of the board and the PCB design, and also the 3D model, the CAD file. Yeah. And then you will need to provide power budget also, and you need to compliance to requirements. So this phase, when you do the engineering model, we will select 5 themes, and that 5 team would be the winning team, and then we have to develop the flight model also, and we show you on this schedule. So you will have around 3 months of develop for the engineering model board, and you will need to submit the EM board to us in the end of August. And you will have 2 months of testing, environment testing, and evaluation for 5 teams. So we will announce the winning 5 teams in the end of October, and they will need to develop their flight model in 2 months and send to us in the end of December. And after that, we will do the integration and test and so on, everything before we hand on to the JAXA to launch. So yes, and this one is the whole schedule for the competition for before launching. So for the first phase will be in the end of February. I mean, the application deadline, and we will announce in the middle of March. At the same time, we will start the second phase, and then you will have some time to develop, and you will need to submit the document in the beginning of May, and then we will announce 10 teams of success, the selected team in the end of May. And after that, we'll come to the third phase, would be the engineering model development this time. And we need to submit again in the end of August. And 5 teams, you need to develop the flight model and submit to us in the end of December, right? Okay, next. Okay, so after our satellite is launched and orbiting around our Earth, so this is an on-orbit scenario. So first one, we would like to test the ground terminal and the APRS reference by VHF antenna number 1. And then we also test the ground terminal and APRS reference by VHF antenna number 2. And then we will send through the UHF control data and store it in the flash memory. And then we return on, switch on the payload, APRS mission payload here. Here, I forgot my laser point. And so the computation will start from here. The APRS payload number 1 will send the control data to the reference ground station, the QTech 1. And then the reference ground station will send data to the APRS payload number 1 and store it in the flash memory. This is to test downlink in here and to test uplink in here. So if you are succeed, the payload would send the received data to the ground station through the UHF, and then this one will be the complete of the competition for the payload number 1. So we will switch to APRS payload number 2, and we will do the same method like the phase number 1, and we can do this loop until APRS number 5. And next would be the success criteria. So for the minimum success criteria, we will expect at least 4 boards are selected as a payload and go with the satellite. And for the full success criteria would be at least 1 payload could succeed in communication. This means like uplink and downlink with the reference ground terminal. And the extra success would be 4 mission payloads could succeed in the communication with the reference ground terminal. And next one is the ground terminal competition. So the objective would be the same. So we would like to increase the use of amateur radio communication and improve technical skill and democratize the approach to the space sector. And for the contest detail, we will need you to register by the call sign and your name and address, nationalities and contact information, and also the station information, including hardware reference, radio information, station type, which is fixed or mobile or handheld. This is handheld, the example of handheld like this. And next would be the TNC, whether it is hardware or software, and the antenna information and the position of the ground station. And the last one would be the picture of your station. And for the contest detail, we've used the band at 145 megahertz. And for the entry, so everyone that can contact to the satellite will be winner, but it not would be so excited. So we will do the ranking by this one. So we will divide the category into 3 power outputs. For example, power output up to 25 watts, we will classify in the same rank, and 50 watts and also 100 watts. But this number would be changed after because depends on the country that you are in. Yes, and the terms of the participation. So each participant will have 1 week to contact to the satellite. This one we will schedule for every participant, and we will announce later. And then the participant should provide a proof of communication that you can contact to the satellite, even, for example, log file, elevation data, our power output, and this one will submit in our form or our website. And also, of course, that the ground station operator must have a valid license and must be following the good radio amateur practice, and the information must be correct. And for the ranking, the format for the message exchange with the satellite would be APRS package, and everyone that can contact the and send short message will get 1 point for each. And this is how we rank the point. So every contact confirmed that will be scored by 1 point, depends on the antenna type and station type and elevation angle and cost. For example, if you use the Omni antenna type, you will get to multiply by 2 because it's harder than the directional or tracking system. And for the station type, if you use fixed, you will get only time 1, and But if you use the handheld, which is the most difficult, you will get multiplied by 5, this one. And also for the elevation angle, if you can receive and send in like really less than 20 degree, you will get more than the overhead, like 60 degrees, something like this. And of course, the cost of the ground station, if you if you have super low cost, you will get more point. So that is for presentation. And this one, I would like to show you the website. Please give me a second. Okay, so our website. This one, we will update everything in there, like for example, information of the competition and when is it and so on. And you can also visit us on the Instagram, Facebook, and you can also watch the webinar on the YouTube. Okay, let me show you a website. Okay, this is our website. So we post everything. Now we just post the frequency asked question here. You can also, if you have some question, you can also send us through the social media. Everything we can try to answer, and we also will put in here. So yeah, you can read here. And then you can see that, okay, we announced the webinar. What gonna happen? When gonna happen? You can register from here, and this is the first webinar that we held. You can also watch the video here, and you can submit your application now here already. So, and you can download the application from here. You can click download, and after that, you can submit the application from here. I will show you. And this one, you just put the email and your team name, and together with the YouTube link that you prepare, and you can also upload the application form from here, and together with the consent of open sourcing. Okay, and next I would like to show you the application form. This one is an application form. So you need to fill in your team names, organization, address, country, and every detail we ask. And you need to put your team members' information, nationality, and occupation and labels in here. And you will need to write your motivation why you join the competition, and also the objective and expected outcome, and also the mission definition here, what you're gonna do for the mission, and the block diagram roughly, like what you're gonna have in there, for example, like MCU or TNC or so on, and the concept of operation, this, and plan for the budget. This one would be what sort that you think that you will get the budget from. Yeah. And this one is plan for outreach, to like announce as much as you can to students or to children, maybe, yeah. And last one would be development schedule plan. And okay, I will also show you the field form that we already try to prepare. So for example, our team name is Burst 8, organization is QTech, this one, and fill in everything. And I introduce you the team member already. We have many nationalities in here. And for the motivation, you can describe in the text, or yeah. And the objective of doing this thing, this file we will upload on the website So you can try to study and do the application form by yourself, and also on this block diagram, concept of operation, and where you're gonna get the budget from, and plan for outreach and schedule like roughly like this. And the last one would be the consent. Let me show you. Okay, this is just the consent for open sourcing. So you just need to check this one and put your name and signature and date. Yeah, so that's it for my presentation. So thank you for your attention. Now it's time to question and answer. Thank you.
Thank you. So please, if you have some questions, don't be shy. We're all the team of BirdSex is here to answer to your questions, as well as some of the questions that were already answered in chat.
Yes, from my side. So regarding the antenna, how is it connected to the payload, or are we supposed to prepare a connector for it, or there is some sort of connection in between? So just I want to understand how this is, let's say, planned. Thank you.
Can you go back on the slide? So can you hear me clear?
Yes, we can hear you.
So can you hear me or not? Yeah, okay. So as for the connection, each payload will be outputting a radio signal, a frequency modulated signal from the transceiver, and this signal will be sent through cable to a 6-way RF radio frequencies switch that will manage the incoming signal to the antenna. This part, so the link between the transceiver and the antenna is on our side of the project. You just have to be sure that your transceiver is outputting the right signal with the right power output. But yeah, and also the connector, sorry, the connector will be the model of the connector will be provided in the ICD. It will be normalized for everyone, the same connector, so we can plug everyone on the antenna.
So there is another question from Aaron. Do the teams have to be from the same country? We are not actually expecting that the teams, the persons conforming the team need to be exactly from the same country, but for the development probably will be easier if you are in the same country. So I mean the composition of the team, we don't limit it, but we just ask them to develop the payload and also to have an affiliation. So the affiliation is to be just one, so we can make the MOU in the future for the phase 2 or phase 3. There is another question about what is the maximum number of participants allowed in one team. That's another thing that we're not limiting. I mean, we're having, since one, it could be already considered a team until the maximum, we don't have a maximum limit of participants in one team. Of course, if just one person develops this, it's going to be pretty complicated. So we're expecting a lot of outreach, and we would like the teams to be as big as possible. So you could, if you're a professional, you could teach some bachelor student, for example, or if you're a master's student, you can collaborate with a professional or a PhD. We're expecting like collaboration and outreach. So the more, the better. Is there some other question?
Yes, hello. Do you hear me?
Yes. Yes.
I actually have a question regarding the concept of operations. Do you mean by that the operational modes also getting the telemetry and those type of information? And also the maybe the difficulty here is that there are other payloads also with our payload. So, well, yeah, if accepted, of course. So how do we consider the other constraints from the other payloads? Or do we do it like we, the payload that we develop is the only one on board the satellite? What are the assumptions that we should take in this situation, knowing that we don't know what are the other functionalities of the satellite? Yeah.
So for the first question about the concept of operation, so the concept of operation is how your payload is working, so hardware-wise and software-wise. So we need an explanation on we need the codes, of course, and also how it is working and how it is communicating with our side of the satellite, right? So we can integrate it for the phase 2, we can integrate it in the satellite. Because as you say, there is other system and other APRS bonds, so it needs to be compatible with our payload and overall with the satellite. For the, ideally you don't have to bother about the other payload, but you need to keep in mind that you are part of more globally system. That means that as there were in the other phase, you need to show that your impact is not too you don't have too big of an impact on the other payload. For example, in terms of emission of electromagnetic field, for example, so that it could make interferences with other payload. So you have to minimize the noise, to minimize the interferences, and you also have to show that you have all the security features that we ask. As for example, in one of the block diagram, we ask for OCP that are basically switches. We ask them because if there is any problem, we can shut down the payload completely from the rest of the satellites, so it doesn't jeopardize the system. Yes. So this is the basic safety compliance. This is one of them. There will be other safety compliance, but right now it is not fully. We don't have all the information, right? But we will organize things so that other payloads will not harm each other. I hope it answers it.
But there is no document now that specifies the safety compliances in the application, in the call for applications?
Yes, in this moment, we're like working on it actually. We're working on the ICD. It's going to be soon the ICD, but for this phase, we're, I mean, as Guillaume said, we're planning on you to show what is your concept of operations, right? Many people were asking us if there was a possibility of adding some sensor or something like that for each payload, and we're not limiting on it. We're just limiting on the fact that it should be compliant with the power budget, with the volume and mass requirements that we will have. So this document will be at this stage of the competition. I think it's not how to say, it is important to think about it like since now, but it's not something that it will, how to say, affect the application in this moment. Also, we ask you to implement switches, as Guillaume said, that will be controlled by us. So at any point, if your payload, how to say, fails to pass the safety compliance that we are putting, and the JAXA is also requiring from us, because at the end of the day, we need to also comply with the safety requirements that JAXA asks us. So as long as it complies with it, it's fine.
Yeah, because actually we were we worked with the winner of the JAXA's CubeCube 6th round, and actually in the application they were very, very strict with the safety requirements, and it was the main part of the application. So that's why we are wondering for this one if we should consider it at early phase, or Shall we provide just top level design and top level features, and then if we go to the second phase, then we will discuss it in more details. So you go for the second option in this case, no?
Yes. So I mean, what we plan now is this like dividing stages. We could call it like that. So at the beginning, we need people to apply, and we need for them to understand what actually they're doing. Like we want them to understand that they're doing a payload and for what they're doing the payload. On the second phase, we will have constantly, as it says in the slides, as you can see, we're going to have constant communication with the teams that are participating, giving, I mean, more updates on the ICD and also on the webinar, because we need to pass the safety requirements. So yeah, we go for the second option of making it together as the project advances, because right now to ask for it for many people it's too much, I think, in this moment.
Yes, I completely understand. Maybe my last question here is, would we have the opportunity to send uplinks to the payload, or is it possible to be pre-programmed or for the operations? I mean, or to get the telemetry? Is there will be actually a loop to communicate with it, or just for the downlink that will have access? Yeah.
So for the competition, we plan the on-orbit competition, as you see in the scenario that Melissa showed. Thank you. So this on-orbit scenario will only imply that we communicate with the payload, right? But after the competition is finished, we will allow the team to use their payload as they wish. We will, since we will have communication with them, they can send us to ask the permission to communicate with the payload. We will turn it on for the time being when they need it, and we will organize the schedule of the satellite to be fitting some of the mission if they want some of them, right?
But this is just for receive for the downlink, but to send commands for the payload, it should be always through QTech. Is that the case?
Yes. We are the only one that send commands to the payload, right?
Okay, that's perfect. Thank you very much.
No problem.
Is there some other question?
Maybe just out of curiosity, I see that there are a lot of nationalities from the team. How did the team formed actually, and are you part of LACEN in QTech, or how do you? What is the framework that actually unified you?
So most of us are students here. Like we're new students that just recently arrived. Most of us like 4 months ago. We're part of the Space Engineering International course of QTech. And at the same time, some of us are part of the PNST program. That is a program between UNOSA, I believe, the United Nations, and QTech to give a scholarship to people from developing countries to come and study their postgraduate degrees on aerospace engineering. So yes, like this team is multinational and multidisciplinary. So there's people that specialize in mechanics, there's people on electronics, there's people on thermal, there's people like on robotics. So we're like a very diverse team. That's how we came up together.
Nice. It's very interesting. Yeah.
Thank you. Yeah. Some other question?
Yeah, well, I see there's no question, so I will give my one more question regarding the budget. So is it going to be for the development and testing of the board plus also the shipments? Are there other considerations we should take? And do we need just the engineering model and the flight model, or do we need more models? So this will help us actually to have a realistic budget. What would be included in the budget besides what I just mentioned?
So right now we're considering to have the budget. It includes the Redbird model, the engineering model, and the flight model. So we're planning to add these things onto your budget, right? We want to ask how you're going to get the funding to complete your project. As well, like apart from the shipment and from all of these component parts, we're not asking for anything. The environmental testing and every other expense that happens, like by testing or by the integration, it's on our side. So yeah, like I think like the budget is just how you're going to secure the money to make sure that like you are able to produce the engineering model, the flight model, and the breadboard model.
And also, if I can add something, we will surely ask each team to have in the phase 3 to have a spare flight model. So if there is a problem with the one they send for testing, they have one in backup.
Okay, so at least there will be 4 boards to be developed at least.
A breadboard model, 1 engineering model, and 2 flight models. So we have
so
4 models.
At least. Okay.
Yes.
Yeah. Okay, that's perfect. Thank you.
No problem.
And actually, yeah, I think there is another question. Sorry.
Yeah, it's okay. It's okay.
Well, hello guys, it's Juanjo. So
Hello.
I was my understanding was that the amateur radio license was mandatory for the ground station competition, but not for the APRS payload. But then I read that it is also mandatory. Is that, am I correct?
Yes. I mean, the license, we're not asking since the first phase because you're going to need it more for the testing of the communication with the board. So like, I mean, for testing, you need the license to comply with all the rules of the radio community.
Okay, I understand. Thank you.
Yes. So also to add on this, to make clear, like on the team, we just need 1 person from the team to have the license. The person that is going to, how to say, operate during the testing of the boards. So I mean, that doesn't mean that not all the team can have it. It's even better if everybody has it, right? But at least 1 person from the team should have a license, just to comply with the rules that like of the communication.
Is this for the APRS payload or for the ground terminal competition?
From the ground terminal and for the APRS payload. 1 person from the team should have a license.
Okay, prior to the application in 28th of February?
No. We are asking for it, I think, by phase 2. So okay. Yeah. So by phase 2, you should have like a license. I know sometimes in some countries it's hard to get, but one thing that we found from many countries that you can find a radio association that is in your country, and many of these people already have license. So there is a way to convince them to work with you or with them. Also, these associations usually get good funding and they're interested into the development of APRS. So that could be a good solution in case it is complicated to have to get a license in your country.
Okay, and could it be a good solution to have the national authority that authorizes the frequency that gives the frequency allocation on national level to have it as a partner for in this project, or no? Could it be an advantage?
I mean, yes, as an advantage, like itself an advantage. I don't know in terms of like choosing or like how to say the decision that we're going to make, but for sure it's going to get easier to about the licenses and maybe the expertise that they can give you. So yes.
Yeah. Okay, that's clear. Thank you.
Yeah, you're welcome.
There is a question. There is a question in the chat. What if the country does not have licensing procedure for APRS? So APRS is one type of radio communication, so you need a license from your amateur radio community. It's not a specific license because it is one of the amateur radio community frequency that can be used by any licensed person. So yes, there is no specific procedure for APRS.
So if there is right now, I mean, you can continue to ask questions, but I would also like to show the field application form because many of you ask about it. Maybe an example, like there was a question about like showing an example of it. So this is not exactly what we want you to do. So we don't want you just to see our example and maybe copy paste it. We want you to be original on what exactly you're going to make. So the field one. Right. So yeah, like, I mean, this we just feel is for you to see more or less what we expect. You can change the things or the way that you do this, you fill this application form, since we also appreciate individuality, and we understand that like each project is itself, and we give points for the quality of application. So we could show, yeah. So here is the application form completed. Let's suppose we just fill the information with our team information. So our team name is BirdsX. Our address, like it's here in the University in Fukuoka, the city, the country, the phone number, email address. Going down, we start going with the points that we show in the presentation. Here is the team members information. So I'm the project manager for this project, for this satellite. So I could be the point of contact. If we need to have communication with your team, we just expect to have one person with communication. So we don't need to message the whole team, right? My nationality and my occupation. I'm a PhD student in this moment, so that's the whole team. There is Marisa, there is Guillaume, Javier, Tasuku. This is the whole team of BirdsX. We can go ahead. Here is the motivation. So here, as we ask, the motivation for joining the competition. What is my motive for this? So we're a group of students with a passion for space technology, and we believe in the potential of nanosatellites, APRS communication to revolutionize space. Then we go to the objectives. Here we got like what we expect to do, or the expected outcomes of the mission. Which one is our goal? Our goal is to provide a low-cost, reliable, and effective method of data communication for remote, inaccessible areas. The APRS can be used for this, for storing and forward. So then we go ahead. This, by the way, this document is going to be available on the website, and probably we'll also put it on Facebook, so you can access from this place. The mission definition. This is what some people were asking. Here is how we plan to develop the payload. So this project aims to design and develop APRS payload that can effectively store and forward VHF packets, and to participate in the APRS payload competition held by QTech. So our team will use a systematic approach. So this is just a description of how you plan to implement the mission. Then we go ahead to the block diagram. We put here the same block diagram that we presented during the webinar, because this is the example that we try to give, right? Something that has like, it's just the basic components in this moment. We're not asking specific about the components or specific locations, but just to have a functional block diagram of what you plan to do, because we also need to understand that you understand what you're doing in this moment. So we can go ahead. And the concept of operations, how is it designed, how it will receive the power supply, which beacon message you plan to give, how the purpose of the storm forward, how the system works itself. Then we can go to the next. The plan for budget, as we said, we don't expect you to give us a definitive way of like, I'm going to pay, I don't know, $500 for this or $200 for this. We expect you to explain us how are you going to assure this budget, how are you going to engage the community, or how you're going to engage your affiliation to go for this funding, or like who is going to give you this funding, how are you going to make sure that this money actually comes, and that like by the end you will be able to comply with let's say if you reach to the third phase, to give us the payload at the end, the flight model. Then we go down, and this is a very important part for us, because our mission also, apart from the satellite, it's to give more information, to share the outreach of the APRS and radio amateur community. Since one of our, as Marisa commented during the presentation, one of our funding stakeholders is the ARDC. So we care a lot about this. We care a lot about if you share on YouTube, if you share on LinkedIn, on Facebook, that you're participating in this, and that you can bring as many students as you can, as many professionals involved into this project. As well, like the last point, I believe, is the development schedule plan. So this is what we want. Maybe a little bit more detailed on, if you have more experience, of course, it's going to be more detailed. If you have less experience, it's going to be something like this. Let's say you start to develop the payload, the procurement, the programming, the finishing, or the evaluation period in there, and the way that you send it here. So it could be also a Gantt diagram. It could be like a way, like a table here. So what I'm saying is it's free for you to do it how you want, considering that we're going to qualify it, and that on this depends the pass to the next stage, the next phase. So yeah, that's it. Thank you. I don't know if there's more questions. You answered to the questions?
Yeah, I'm answering now.
Okay, so how many points of contact should be in a team? As I said, we expect just one person to be the point of contact. Maybe, let's say, in an inside, you could have like a general mail and one person taking care of it, but we're just going to contact with one mail because the competition, we expect many participants, so it's going to be pretty hard for us to connect with everybody. Yeah, the next question, do all the members should be in the same college?
So I was answering on the chat. So as said, we need the team to be affiliated to an organism, whatever it is. It can be university, companies, or an association, because it needs to be legal, a legal person, so we can sign an MOU. But it doesn't mean that all the members should be from the university, for example, or the company. If the university or the company or whatever is okay with having outside members joining the team inside the university, it is okay. So we don't expect them to be all from the same university. If it answers the question.
If there is any more questions, please ask them. As I said, like all the subsystem and all the teams here, so we can answer to any question that you have.
Yeah, if we have two institutions that will apply in partnership, shall we first design one that will be kind of the leader between the two of them, and shall we also duplicate the team information part and fill it for both institutions with the information and mention maybe one contact from each institution, or how do we manage it? Yeah, please.
Okay, so I think, I mean, we didn't really contemplate having like two institutions, but if it's really necessary that like these two institutions are, and it's a very specific case, we can discuss about having the MOU with both of them. Like, I mean, just having more MOUs is actually better for us. So if there are two and they agree between them and there is not any type of like complication. Yeah.
Okay. Yeah, because actually it's a governmental institution with an NGO, and we are very complementary. So they have the infrastructure to do the tests, to develop also the boards, and also they are willing to support in terms of funding. And from our side, we have the expertise in the space sector. So we are very complementary, and that's why we want to promote the collaboration between institutions in our country. So that's why we are working on this type of collaboration. So there is no problem with that. So we put the information on both institutions in the first part.
Yes. I think there is no problem. As I said, like maybe it's a very specific case, and both of the institutions will need the MOU like for their own purposes. But like we're not. I mean, we as a team we cannot get inside of how do you decide like your establishment between these two institutions, but like maybe we can talk about like when the moment comes.
All right. Do you have an email where we can maybe send some specific questions, like even for the form of the application? If you have some doubts, if you can share with us any email address, that would be very helpful. Thank you very much.
Yes. We will share it right now in the chat, and also. Yeah, I will ask my teammates if we can share right now in the chat. If not, I will send you a personal message when we have it.
All right, thank you very much.
There is the email.
Or yeah, I mean, just we're discussing if we could use one email that we have. So if you want, I think you can let's say save it. This is the email that we have. No? the Gmail. So it's
okay.
Well, anyway, I will contact you in a while, and I will send you a message with all the information.
All right. Thank you very much.
Thank you. So is there any other question? So yeah, the mail they shared it like on the chat, and as well, we're going to share the Gmail contact. We're taking care of both of them. So, is there any other question? Please, you can ask us whatever you want. And consult with us also, like if you have any doubts, we're soon also going to be posting on our social media and the website personal information about the team members. So if you want to personally contact any of the team members, I think we will be more than happy to answer to you. So if there is no more questions, I think we can finish this webinar. I just want to remind you the next webinar is going to be on the 8th of February on the BERT's open source webinar series that we have here at QTech. It's going to be given by my colleague Javier Ferrer from Paraguay. At the same time, I want to remind you, apply soon because the deadline is coming. So we expect to see you all in the competition, and we expect to see you successful and part of our satellite. Thank you and goodbye.
Thank you. Have a nice day. Bye-bye.
Thank you. Goodbye.
Thank you.
Good. Yes, good.